going to have to correct me on that pronunciation. Thank you.
Thank you very much. It's a pleasure to be here. I'm actually going to be talking to you something about a topic that's actually quite frivolous, given the fact that you're talking about important things with society and water use and animals in the forest and all of these kind of issues. But wine has produced a very interesting kind of topic to couch climate change in that I've been working in a long time. I'm coming to you as a climatologist that has looked at this for 25 years, but I'm also a producer. My family has about a 90-acre vineyard and winery in Oregon, and I know what it takes to grow grapes and make wine, so I'm coming at you from a couple of different directions here. So what I'm going to try to do today is to talk about this collection of things here. We're going to start off with talking about the changing wine map and this magical issue term called terroir. Look at structure and suitability for wine production, what the past and the future in terms of climate changes look like, and then summarize everything from there. So I just wanted to kind of start out here because there's a very large amount of change going on in the map. This is just a map of areas that theoretically can grow grapes based upon their growing season temperatures, and then defined wine regions out there that have been noted by governments across the world. Now, a lot of different things are going on. Number one, two big players are coming onto the scene. China especially, but India as well. China right now has planted more grapes in the past 15 years than all other regions in the world combined. So it's a big player. We also have a whole series of subtropical to tropical regions that are becoming more and more prominent. Different challenges there, of course, climatically. Typically what they are looking at is how to manage a plant system that wants to produce 2 and sometimes 3 crops per year, which is really not very efficient for grapevine. We also have a whole series of old world places, whether they be Eastern Bloc or even in Turkey, that are trying to reinvent themselves in terms of wine production, using less indigenous grapes and using more kind of international known grapes. And then we also have a whole series of fringe areas, the places that are on the poleward fringes of production capability, whether they be in the southern hemisphere in Chile or Tasmania, or up in parts of northern Europe or northern North America. Now, change factors are many in terms of the wine industry, but I want you to kind of go through these real quick just so you know what's out there. Number one, there's growing demand, changing demographics worldwide in terms of how we're pursuing and drinking wine. Number two, international and national economics are extremely important in terms of how the industries have developed worldwide. There's also many new markets. Again, India and China learning to drink wine is a very big deal for this industry. And they're producing new consumers, but also new styles of wine. We're also seeing new purchasing trends. If you haven't seen it yet, there are vending machines selling wine out there today, and you'll see more of it. There's also changes in the tastes that are occurring, not only for us as a public, but also the people that kind of tell us what to drink. Their changing nature also is very important. We also have production and movement of bulk wine like nothing that we've seen historically. Today, large-scale producers are sending wine to offshore areas in big containers, bottling the wine either in a different country or bottling the wine on the ship just offshore and taking it onshore. We also have a whole movement to organic, biodynamic, and very interesting sales going on in terms of that. The other is that there's always pioneers in this industry looking for the fringe. The fringe is right at the cool climate margin because that's where special wines can be made, and most people are still looking for that. All of this is happening with changes in climate in mind. And there's just a lot going on out there. I'm going to try to couch it in terms of what we know from the climate aspect of things. So I need to get to this term terroir. Terroir is a French term. It's been championed mostly around agricultural pursuits or product production associated with the natural and cultural environment that help produce that. But virtually all things have terroir. Honey has a taste, it has a terroir. Apples, maple syrup, oysters, my grandmother's tomatoes, they all have terroir in one way, shape, or form. It's just that wine is where terroir kind of originated and how it's mostly talked about. So when we look at this, I like to look at it as inputs and outputs into the system for producing wine. The first side is the input side. We have 4 different things that are important: the variety that is chosen, the climate that it's grown in, the landscape that it's grown on, and the soils that it's grown in. However, all of these are tied back to cultural factors. And probably the most important in the whole system is really that you choose a variety to plant in a given place. You need to be able to do this in terms of all of these other characteristics, but especially in terms of the climate. Because if you don't get the climate right, nothing else works. This here is essentially the construct of terroir, that we know it in terms of the wine production system. We can also look at the outputs that happen from growing grapes and making wine. Of course, a given terroir will produce a given wine style. These typically are a little bit more broader speaking kind of characteristics, but wine styles are very driven by place. There's also factors of quality. You probably have heard of quality factors such as a Grand Cru in Bordeaux is different than a Cru Bourgeois. It's just site differences. It's essentially terroir differences. We also have production issues that come from the sense of place. And you take those outputs, a lot of people today also talk about this idea that marketing is behind terroir. You can't help but see that written on most labels and talked about virtually at all wineries today. I also like to kind of couch this in terms of something that you see within the industry. On the left-hand side is, here's a debate going on. Left-hand side is a grape grower talking to a winemaker. And winemakers today have been kind of tagged for blending terroir. They take grapes from different places or different regions, different countries, and they blend it together, and therefore terroir is kind of gone. And so a lot of people in the industry tend to look at this as being, this is the terroirist, and this is the terrorist. So we see this quite a bit of. So climate's role in terms of the expression of terroir is pretty straightforward. And all of you experience this, you know this. But it's pretty straightforward. You've got this cool climate to intermediate to warm to hot climate structure that drives fruit style, body, flavors, acidity, alcohol, and the overall general style of the wine. For example, a cool climate wine tends to be fairly lean, a little bit more elegant, light, alcohol is very low, and the characteristics of the wine are very subtle and very finesse kind of. If you go to a warm to a hot climate, varieties that typically are produced there typically have more lush characteristics to them, more kind of cooked flavors to some degree. The body is a little fuller, bolder, and the alcohol tends to be higher. Now, geology and soil does not produce these general differences, but the subtle differences are expression of them within a given region, within a given vineyard, that kind of thing. Climate is the one that does the first cut on this. So if we look at kind of climate structure and suitability for viticulture and wine production out there in the world, this is just a diagram I like to use because it illustrates the point, but I think it makes a lot of sense. You can put this on an XY axis where you have climate metrics, typically more temperature driven, and then production or quality metrics on the y-axis. And the relationship is straightforward, it's parabolic. We know that in any given vintage or any given wine region in the world, there's a too cold of a threshold where you're not going to get the right sugar levels, the flavors are going to be unripe, and then you're going to have unbalanced wines. We also know on the other side of the coin that there's too warm of a threshold where you get lower retention of acids, overripe flavors, and unbalanced wines as well. Somewhere here in the middle, it's optimum. This is what you look at. You look for putting the right variety in the right place so that that optimum zone is more consistent. We know that vintage variability is a big issue and that untimely characteristics will drive some of that. But this has largely been my research for 25 years now, trying to look at these bounds or these thresholds by which varieties are grown worldwide. And in terms of climate change, I think what we really need to understand here is that how much plasticity or adaptation, both in a management framework in the vineyard versus a varietal framework in terms of how it manages change over time. We have some ideas here, but a lot of this is still relatively unknown. In doing this, looking at these threshold issues, I've put together some things. I've been collecting data on varieties for many, many years, looking at just really how growing season temperatures as a very simple construct can decide where we grow grapes. Growing season temperatures in this case are April through October, very similar to growing degree days, depending on how you might look at the data. But the idea is that we can look at varieties and see that they have these climatic thresholds for optimum quality and production out there in the world. And I'm going to give you an example. We can look at Pinot Noir. Pinot Noir has a fairly narrow climate niche. Oh my gosh, 5 minutes. That just blew me away. So anyway, Pinot Noir has a very narrow climate niche for production of high quality wine. From what we know about it, it's about 4 degrees Fahrenheit globally. You can take, for example, Burgundy, kind of the historic home for Pinot Noir. The vertical line is its 50-year average. It's centered to Pinot Noir's window, and the bars horizontally or its standard deviation. So in cool years, it's still there. Warm years, it's still there. But stylistically, the wines are different between those types of years. We can also put bookends on it. One of the coolest places in the world today producing quality Pinot Noir is the Tamar Valley of Tasmania. And one of the warmest is the Russian River Valley. Now, climate change would ask us, what happens out there? Most of the Pinot Noir produced in climates out in this type of area typically are bulk wine. They typically do not go into high-end quality production. So that's the concern that we have looking forward. So if we look at this as a system, and I got to go through this really quick at 5 minutes left, we have to look at it as a system because it's a little bit more complex than just these average temperatures. We know that during the winter, from one harvest to the next bud break, we need a slow hardening of the vines, chilling units, not quite as much as we need for other horticultural crops, but then also low winter extreme temperatures. We also need to know aspects of soil temperatures in the spring and how that combines with atmospheric temperatures and daily changes to produce bud break. Daytime temperatures are very important as we get close to bloom. Low rainfall, high solar potential, all of those things produce a very effective bloom and fruit set. We get into a period called veraison. You have to have optimum heat accumulation for that variety. You have to have low temperature variability. You can't have these wide swings. The plants freak out. They basically shut down. You also can't have heat stress during this period. We also, as we get close to harvest, you need high diurnal temperature range. The important thing here is this, simply that if temperatures change more at night versus day, it means something completely different to the plant and the grapes that it's ripening. You also need to be able to be growing your grapes when the season is truncating into cool nights. It's ideal, and if you have a real long growing season like some places today, problematic issues come about from having balanced fruit. I'll show you that in just a minute. So let's look at some change factors. I'm just going to go through these again real quick. We know that in the Pacific Northwest, just like most places in the world, we've seen warmer dormant periods, issues with chilling and hardness, but winter freezes still exist. In the springtime, we know that there's warmer soil temperatures and air temperatures driving earlier growth, but frosts still occur too. Evidence of some slight changes during around bloom in some places, which has caused challenges for flowering and production. And then during the veraison period, we know that growing seasons are longer, higher heat accumulation, but there's more heat stress today in most wine regions, including the Pacific Northwest. And during harvest, lower diurnal temperature ranges ripens fruit too early. We tend to be sugar ripe, but not flavor aroma ripe, and our ripeness clocks are pretty much out of whack everywhere in the world. They have to be managed is really the big issue. Phenology has also shown big changes, and for example, this year in the Pacific Northwest, we had about a 4-degree warmer growing season than average, and we had 2 weeks to 3 weeks earlier phenology. We've also seen a compression in those events as well, and many other things I just don't have time to talk about because I'm going to get pushed here real quickly, but all kinds of impacts that happen from other aspects of the production system as well. So looking to the future, I mean, you could do something as simple as this. This is some old work we did a while back, looking at how these bounds on temperatures might change worldwide, and this is pretty straightforward. You get a polar shift to those isotherms. We did some work looking at wine regions in Europe and got a long history there. We took a random forest model and basically trained the model up to know the terroir of these wine regions. And here's 18 ones that you might know of overall. And when we driven it into the future with a climate model, what we basically saw is a shift in terms of spatial locations of the potential areas where these vineyards are, or these wine regions. The challenge here comes down to, in Europe, these are historically defined regions that I'm not sure they're ready to make the changes. For example, in Champagne, they will have to redraw their borders and their boundaries to make this actually work for them. We can go to the Pacific Northwest. Here's 81 to 2010 climate normals for growing degree days. Pretty straightforward. Blue, cool climate, greens to orange, kind of mid-intermediate types of varieties, and reds, typically hotter type of varieties, but also bulk wine and fortified type of wines and table grapes. If you go to a future looking out at 2041 to 2060, the pattern really changes. And Phil, this gets back to something I think you said yesterday, that looking at 2040 is kind of being potentially what this past couple of years were kind of like. We can look at that and say, well, yeah, we could see that we could grow grapes in a much broader range of places, of areas in the northern parts of the Pacific Northwest. But you go down into California, and many of those places have just become too hot. So clear issues kind of showing up in all areas there. So just a summary before I get shut down. So this is pretty straightforward. Wine production is really a very climatically sensitive endeavor. We have very narrow zones, very unlike corn, soybeans, rice, those kind of things that have a much wider kind of geographic and climatic range. So small changes are very problematic in terms of crop impacts. Climate variability issues are really big in this industry, driving vintage variability. 2010-11 in the Pacific Northwest, relatively cold year, and we have very different wines that came out of those vintages compared to 2014, in which it's on the complete other end of the spectrum for the temperature distributions in these regions. If you look at a meta-analysis for wine regions worldwide, 2 to 8 degree warming by 2050 is kind of what's out there right now, and most will see conditions in that period, about 2050, that are very similar to what we've seen in Europe, Australia, the Western United States the past few years. We know that there has to be some adaptive capacity that is examined within the industry. We also know that terroirs have to change. If you're growing Pinot Noir today and your climate now says you have to do Syrah, you better really think about doing that. So I thought what I'd leave you with on this last slide is a series of things that I'm seeing within the industry that are helping them reduce vulnerability and increase their adaptive capacity as they're looking at climates of the future. One is that there's a large genetic potential out there in terms of grape material. For example, there are varieties in Greece, southern Italy, parts of Spain and Portugal that produce very well within a warm climate and can be potentially used as a genetic source for other varieties to produce in warmer environments as well. There's also a large landscape potential for adaptation. We just have to be willing to allow that adaptation to occur, and in places in Europe, being willing to realize that some boundaries may have to change because of changes in climate. We also have to look at how vines are trained. Well, how we used to train vines historically, and then today may be very different in the future given some of the changes in climate. I just saw something yesterday that came out looking at using shades in vineyards to help keep solar radiation impacts, high temperature impacts down. Optimization of geometry of the canopy, row orientation, shading materials, as I said, all of these things are kind of adaptations that growers can do, but you got a long-lived plant system. And so you have to think about a 40, 50-year window in terms of when you plant that, what you're going to get out of it. And then we have to understand kind of how both the scion, the main plant material, and the rootstock can function within a given place that may have a climate that is drier and hotter in a given region. And then lastly, understanding water use efficiency. Grapevines are very efficient, but we have to put it in the framework of kind of how we're using water in certain places and whether or not water is even available in some places. In Europe, irrigation is not allowed in many places, but the governments are starting to relax those regulations and allow it. It could put a lot of strain and stress on water resources in Europe overall. So anyway, I hope you've learned a little bit from this and be happy to take some questions. Thank you.
We have time for one quick question.
I had a quick question about the too cold threshold that you were showing earlier. And to clarify, is that a threshold at which, or below which, the quality of the wine is declined, or is it some threshold where you also see production, like your yields decline, or maybe there's damage to the vine?
It could be a little bit of both. It's more likely to be related to the grapes not ripening completely, so you have underripe fruit. The production side of things can also be driven by being too cold, but more likely being driven by untimely rain, untimely cloud cover, disease, other kinds of issues like that.
I guess.
Thank you. The image that you had of the Northwest in California, current and then future, I think that was RCP 4.5, and I'm wondering if you have the same image for RCP 8.5 and if it looks very different.
I don't have it with me, but it does look very different. And what typically shows up between the two is what you would expect. You see in the Pacific Northwest especially, we see large changes of more land that is theoretically suitable. Okay, so we see a lot of that. But places like parts of inland Washington and parts of Oregon, the changes there make them shift into a completely different varietal mix. But there's still potential. When you go down in California, there's a compression of suitability much more toward the coast. The Central Valley becomes almost not suitable whatsoever. And it pushes it even past table grape production. And so that 8.5 is clearly the bigger impact.
Thank you. Let's give all our speakers a round of applause.